Hello, my name is Danny Stout. I'm a senior solutions consultant with TIBCO. I'm going to talk about TIBCO data science, specifically about nodes that you find in Statistica, which is the in-memory capability of TIBCO data science. There are three types of nodes in Statistica: the standard node, the SVB node, and the general code node. First, the standard node. This node, whenever you place it in a workspace, is shaded when it has not been completed or it has not been ran. And you can actually see a shaded node on your screen right now. Whenever you run this node, that shaded portion goes away. It becomes white or clear. That lets you know that the node has been complete or ran. Some of the benefits of this node is that you can actually select variables on the node, which we'll see whenever we complete a workspace here in a few minutes. You can also provide greater flexibility in controlling the parameters of the node, as well as the output from the node as well. And when this node is a modeling node, it's automatically going to generate not only a PMML or predictive modeling markup language node, but also a rapid deployment node for scoring. The next node is a SVB node, or a Statistica Visual Basic. With these nodes, there's no shading to indicate whether or not it's been complete or not. On the screen, you'll actually see an SVB node, and it has not been completed, but it is still white around the edges. Most importantly, at the top, you will see SVB. This indicates that this node is, in fact, an SVB node. Some of the criteria around this node is that you're unable to select variables on the node. And the best practice is to select variables using a select variables node immediately before the specified node. This node offers less flexibility in controlling the parameters in the output, and also modeling nodes of this type do not automatically generate predictive modeling markup language nodes or rapid deployment nodes. Therefore, whenever you use these types of nodes, whenever you're modeling, you first have to deploy the PMML, and then you have to consume the PMML using PMML nodes, and then manually include a rapid deployment node in the workspace to score the data. And finally, our general code node. This general code node looks just like one of our standard nodes, but actually these are containers for other types of code. We use this whenever we code within these workspaces in R, Python, Spark Scala, C#, and also Visual Basic. Parameters can be created to pass through to the code within these nodes. And these nodes are ideal for managing code within a no-code or low-code environment. We found them to be particularly helpful for enabling the citizen data scientist to use complex code within a GUI-based environment. So what does this look like? I'm going to go over to Statistica, and I have a workspace ready that has data embedded within the workspace. And the first thing I want to do is show you one of our standard nodes. So I'm going to go to our data mining menu that contains all of our algorithms that are not driven by some sort of underlying theoretical underpinning. And I'm going to choose a regression tree. I'm going to use CART. Whenever I place this node into the workspace, first you'll see that it is shaded around the edges. This means that it is either a standard node or a general code node. But in this instance, it's one of our modeling algorithms. So it is one of our standard nodes. Our general code nodes are only on the Big Data Analytics tab within the App Market or Hadoop program groups. So I'm going to go back to the Data Mining tab, and I'm going to go back to our CART node. Now, one of the indications that I said was that it's shaded on the outside, but also when you click on the node and edit the parameters for the node, you can actually select the variables on the node. So I'm going to select variables for this problem. And you'll see that once I start looking at the parameterization for this algorithm, I can go into very great amounts of detail into this particular algorithm. And it's going to change algorithm by algorithm. You'll see that for CART, I can change the stopping rules or the stopping parameters. I can implement v-fold cross-validation or even include surrogates in the model as well. So I get a lot of control over how I can parameterize this algorithm. I can also control to a very fine-grained level what results that I want. So if I wanted an advanced scrollable tree or a bar graph of predictor importance, or I want to include some prediction statistics, or I want to change what code is generated, or if I want to generate some downstream data for continued analysis, I can do that. Now, once I run this node, you'll see that it goes from the shaded background to clear. This lets me know that the node has been complete. And now I can look at the results for this node and continue looking at the results for this. But what about our SVB, or Statistica Visual Basic node? With this type of node, you do have to select the variables. If I were to go in and include a SVB node, and I'm going to do regression trees and connect this to my data, you'll see when I edit the parameters of this node, there's not a way to select variables on this node. So what we do, best practices, is to actually select the variables preceding the node. So I have a select variables node. I connect the data to the select variables node. I can then designate either a continuous or categorical dependent variable, as well as all of my predictors. So I have to select the variables other than directly on the node. Moreover, I have a little bit less control of the parameterization of this algorithm. So you'll see that I do have some stopping criteria, some options for v-fold cross-validation, but not as great of control over the parameterization as well as results. So for results, I have 3 options, either minimal, comprehensive, or all results. For this example, I'm just going to choose minimal. So when I run this node, it's going to generate some output, but you'll see that our standard node actually generates a node that contains the PMML, as well as automatically generates a rapid deployment node. For SVB, whenever we're modeling, what we have to do is we have to actually include the predictive modeling markup language with the model. So I'm going to have to go back into deployment, generate PMML code. When I run the analysis this time, when I go to the reporting documents, you'll see that I actually have the PMML. So I have to either deploy this to Statistica server, or I have to save it to some local disk. And then in order to connect it to the rapid deployment node, I have to use the deployment features of Statistica. In this case, I'm going to include a PMML node. I have to locate the PMML from disk in this instance. Then, if built for the same dependent variable, I can now connect it to the rapid deployment node. I can now pass any other data through to that rapid deployment node, and it's going to score all the data utilizing both sets of PMML code. Now, finally, what we have is our general code node. As I mentioned previously, on the Big Data Analytics tab, you'll see that we have nodes for C#, Python, R, H2O, and Spark Scala. When I include one of these nodes within the workspace, you'll see that I can program parameters into this node. So if I wanted to create a string for file name and pass that file name through to the code that I include, I can do so. When I get into the code portion of the node, you'll see that we can look at IronPython, which is an option. I have 2 flavors of Python on my local system: C#, Spark Scala, SVB, and R. I can write in any of these types of code that I want, and this is the reason why we call this the general code node. So those are the 3 types of nodes within Statistica, the in-memory capability of TIBCO data science. We have the standard node, the SVB node, as well as the general code node.